Hi, this is Peter Weiss, and this is my vending machine circuit for extra grade. And what I have here is a circuit on Logism where, of course, we have a clock, and we have signals for when we get a quarter, a dime, and a nickel in the vending machine. And then this is the button pushed to release whatever we're vending. This isn't exactly an FSM because there's not exactly much output being fed back to input, but I didn't really think an FSM was necessary, a full FSM was necessary here, so this is just a circuit that basically does the same thing. So what this circuit does is it takes the nickel, dime, and quarter signal, and if there is a nickel, dime, or quarter, what it does is that puts this input onto this basically bus using tri-state buffers. And of course you can't have more than one of these at a time because you can't insert more than one coin at once. So we only ever have one of these, and if the input is high, it enables these buffers, which have these constants here, for 1, 2, and 5. Now 1 represents 5 cents, 2 represents twice 5 cents, or 10 cents, and 5 represents 5 times 5 cents, or 25 cents. So we basically are counting in increments of 5 cents because there's no increment smaller than that because we don't have pennies. So what that does is it puts that input into the full adder in this B input. Now this A input is the output to this register. This register stores the current value of however much money is in the vending machine. This input gets fed back into the A input. So every time these are high, it adds however much money there is to how much more money there is. However, this sum only gets stored in the register when one of these signals is high. So if you don't insert a coin, this load signal here is not going to be high, so this register is not going to change. If you do insert a coin, then the sum will be added to then this value will be added to the current value, and the sum will be stored in this register, but only when one of these, so quarter, nickel, or dime, are inserted, you add that value. So it basically just every time you insert a coin, it adds that value to this register. And this register actually has an asynchronous clear and a synchronous clear. So the asynchronous clear is just so I can reset it to start the simulation, but the synchronous clear is activated once we dispense a coin. So this will count, and we will get to a certain value, but once we get 12 or more, which represents 60 cents, because 12 times 5 is 60 cents, once we get to 12 or more, then we will be able to dispense a coin. We won't actually dispense a coin until this button is pressed, because you need dispense an item, not a coin. So we won't actually be able to dispense an item until the button is pressed, but once we get to 12 or more here and the button is pressed, we will dispense a coin. As soon as that happens, on the next clock cycle, this will be cleared back to 0 so that a new customer can use the machine and no money will be inserted. So if we begin the simulation by resetting it, initially, this is set to 0 because it was just cleared, so there's no money, and if we clock it, nothing happens because there's no coins being inserted. But now let's say we insert a nickel, and we clock it, that will be added to the value of 0 that we had here, and now we have 1. And this signal's not high because we're not up to 12 yet. Let's say we had a quarter. We clock it to add the quarter. Now we are at 30 cents, which is still not high enough for us to be able to dispense. So even if we press the button, nothing will happen. We won't dispense. We won't get any output here. Now let's add another quarter, so that'd be 55 cents. And again, even if we press the button, nothing. Okay, I think we added too many coins. So let's try again. So insert a nickel, clock it, insert a quarter, insert another quarter, so clock it. So now we're at 55 cents, and now even if we press the button, nothing will happen because we're not at 12. We're not at 12 times 5, we're not at 60 cents yet, so we will not dispense. But as soon as we add the other nickel, we will be at 60 cents. And we will be ready to dispense once the button is pressed. So if the button is not pressed, nothing gets dispensed. But once we press the button, we will dispense something. So now, this dispense signal is high, so wherever that signal gets sent to whatever motor will dispense the item, we dispense it. But now this next clock cycle, no matter what, no matter if you keep pressing the button or not, it'll reset this to 0, and it'll reset this value to 0. So no coins inserted and not dispensing. And we can keep playing with this. So 1 dime is inserted, 2 dimes, 3 dimes, 4 dimes, 5 dimes, 6 dimes. So that's 60 cents. Now we are ready to dispense, but it won't happen until we press the button. And we press the button, and something is dispensed, and now we reset. And we see if we press the button and we don't have enough coins, nothing will get dispensed. And of course, this is all on a clock, but ideally this clock should be fast enough so that it will be able to catch the button press, because again, the button press only matters if this signal is high, if we have inserted the amount of coins. So as long as the button is pressed for a sufficiently long duration, which it should be if the clock is fast enough, we will always be able to dispense something. And as long as only one of these signals is high at once, which it should be, because not going to insert more than 1 coin at a time. And obviously there would be a lot more circuitry before this to make these signals nice and clean, make them 1 clock pulse as opposed to holding them for a longer duration of time, but that's not part of the FSM. So these are nice clean 1 pulse synchronous signals that are sent in here when you insert a coin. And this is the FSM that's designed to take those, there's that pseudo FSM, I guess, designed to take these signals, and once you get up to 60 cents and the button is pressed, it'll dispense a coin and then immediately reset. So this is my circuit design for the vending machine, and once we get signals, we should be able to hook this up and connect this dispense to the output so we can dispense an item once enough money is given. Thank you.